Hi Gators, this is Trig Functions Part 2. We're going to be taking a look at the properties of trig functions and some of their transformations and their periods. All right, again, a reminder of the unit circle and how you should be looking at cosine and sine for the special angles. Let's find the exact angles for the reciprocal functions. Okay, so we know that this represents the reciprocal. This is actually 1 over sine of theta. I'm going to write it right now, but most of us just think about it in our head. So we're looking for the sine. We know that's the short length, and the sine here is -1/2, and we want the reciprocal of that, so the answer is -2. Okay, cosecant is the reciprocal of sine again, so it's the same thing. And this time the y coordinate is the long leg, so this is -√3/2. And we want the reciprocal, and the reciprocal would be -2/√3, which in my class you can leave it, but if you want to rationalize, then this is what it would look like. Secant is the reciprocal of cosine. Again, I'm writing it, but most of us just think it. And we're looking at cosine. Cosine here is the long leg, -√3/2. And so the answer is -2/√3. Cotangent is the reciprocal of tangent. And so remember that this is going to be adjacent over opposite. So adjacent is -1/2 and opposite is -√3/2. And so the answer will be 1/√3. You can leave it this way or you can rationalize if you like. Secant is the reciprocal of cosine. So we're looking at the cosine right here. The cosine, both of these are the same. This is -√2/2. Some of us also, you can write it as this, 1/√2. This is the unrationalized, this is the rationalized. And so we want the reciprocal, and the reciprocal will be -√2. Cosecant is a reciprocal of sine. And so my sine is going to be my long leg, which is √3/2. And that reciprocal is 2/√3. You can leave it that way or you can rationalize it. Cosecant is the reciprocal of sine. And right here, this is 0, 1, and the y coordinate is here. So this answer will be 1. Cotangent right here, we're taking a look at the reciprocal of tangent. They are both the same length because the reference angle is pi4, so these are both the same length, except that this is negative and this is positive. So adjacent over opposite will be -1. Let's go ahead and have you stop the screencast and see if you can do these on your own. And here are the answers. Let's take a look at some more. Stop the screencast and see what you can do. And here are the answers. Remember that the period for tangent and cotangent is pi, and the period for the other trig functions is 2pi. Let's talk about even and odd. Secant is viewed as an even function. It has this symmetry with respect to the y-axis, and so the secant and the cosecant will both be what we call an even function. And maybe go back to the other ones, and the other 4 basic functions are going to be odd. Let's go ahead and find all the trig values for this situation in which the sine of theta is equal to -3/5 and the tangent of theta is less than 0. Tangent is where sine and cosine are going to be different, and that's going to happen in the second quadrant and the fourth quadrant. Tangent will be negative in those 2 quadrants. Okay, when I look at sine though, sine is positive in this quadrant, And so I don't want this quadrant right here, so I know I have to draw my picture in the fourth quadrant. So this is opposite over hypotenuse, and if we use our Pythagorean theorem, or you can just see that this is a Pythagorean triple, this length will be 4. Now that we have the length of all 4 sides, the cosine is 4/5, and cosine 4/5, and this the reciprocal function will be 5/4. This will be negative 5/3, and over here tangent is sine over cosine, which will be negative 3/4, and then this will be negative 4/3. Transformations of the trig functions. So remember that A here is a vertical stretch or shrink. It also is a reflection about the y-axis. Adding D is a vertical shift. Over here inside the parentheses with X, that's a horizontal shift. And over here B is a horizontal stretch or shrink and a reflection about the y-axis. Over here A is viewed as the amplitude, and whatever this B is, 2 pi over B is what we call the period, and so on. So let's use this information to help us answer these questions. We want to find the period, domain, and range, and draw the graph of this function. Okay, so right here we can see that there's going to be a period change. Remember, the period is equal to 2 pi over B. And so since B here is 2, then our period is going to be pi. So this is going to be a shrink. And while it's a shrink, there's also a stretch going on here. There's a vertical stretch. So let's just do these two things right here. We're going to stretch all the way to 3. And this is going to be a stretching over here over to negative 3. But what we want to do is we want to be able to do this cosine curve in pi. So instead of going down and up in 2 pi, it's going to go down and up in pi. So we want to make this right here and go up here. So it's going to go down here and then go up right here. And then it's going to do that same kind again in pi. It's going to go down, all the way down, and then all the way up. And we can continue that way. Now let's take advantage of what this does. This is a vertical shift. So this whole graph will now go up 1. This will go up 1, up 1, up 1. And so let's go ahead and follow along again, going all the way down, up, and then down over to here, and then going all the way up. Okay, so now we can answer the question about the period. The period is pi. The domain is going to be all real numbers. And the range is going to be -2 to 4. So it kind of pushed all the way up to 4.